Okay. Last few days you should have finished up section 5.1 and 5.2.
5.1.
5.1.
5.2 started 5.2. Starting with the weekly quiz, I think Monday. I don't have those printed. I should get them printed this afternoon sometime. I think your grades were posted this morning. Everything that we've had so far. I think so far, I'm just gonna look here real quick. I haven't looked lately. We've had 1, 2, 3, 4, 5, 6 grades, not counting the weekly quiz this week. So there'll be 7 grades once I get that in there too. So, just run everything in there. So parent teacher conferences are on Monday. Looks like 4th hour looked good in groups on that day. Last week, we didn't have class on Friday. Most of you said that most of you did very well on the quiz. And so, and then we started chapter 5. I think everybody, I'll get a number more books. I ordered a couple more books, so they should be here soon. This section we're going to start at trig, and this is going to be all new stuff. I'm going to go to the first section, kind of just, most of you did the first section. I know we had knowledge about this morning and came up with radian measures. You knew that answer, so that was good. Do you know the definitions? You've written down the definitions. And one of the things I asked you to do when I wrote down the lessons the other day, and I hope you saw wrote it down, is the outline, take notes on the first section. I kind of hope you took notes. I know there's a lot of notes. The first section and the first quiz I usually give on this section is usually just a couple pages of terms that say define.
Oh.
So it's not really that. They just say define this, define this. And my definition of define is if I could think of a counterexample that doesn't fit your definition, it's not right. Your definition is good enough to fit that description. So as we look at this, we look at a lot of terms as you go through these. It's grades and angles and initial side and terminal side and vertex of the angle. And I think these all are in your first section, standard position of the angle as you go through. I hope you have these written down. Positive angles are rotated around the axis, clockwise. Negative angles are rotated around the axis clockwise, and you should have those definitions down. I'm just going to kind of go through and highlight this because you should be done with the first section. Quadrantal angles and quadrants. I hope you know your quadrants, 1, 2, 3, and 4. They go counterclockwise, start at the left top, and then go around. Quadrantal angles are angles that lie on the axis. Lie on the axis. So as we go through these definitions, there's certain definitions you don't understand, or if you look at your notes and you come to later, you give me a good definition of this, we'll go through that later too. So there's a couple of things to go through. These are the easy ones, degrees. 1/360th of a circle, rotation. Acute angle, or an angle that is less than, what was the definition of acute? 1/0. Zero is a straight. No, 0 is a straight line. When we get into trigonometry, we have negative angles. So when we deal with the acute angle, we're going to say less than, let's say less than 90 and greater than 0. Right angle is equal to 90. The obtuse angle is between 90 and 180, or less than 180, greater than 90. Straight lines, 180. I don't deal with these two, so you don't have to worry about the reflex angle or the complete turn. I don't deal with those two, so you don't have to worry about those. But we will deal with, now we're going to kind of move away from the concept of, when we dealt with trig the last couple of years, a lot of you dealt with trig, we dealt with triangles, right? And the triangles that had up, the only angles we ever dealt with was between 0 and 90. And now we're going to get away from that. We're going to deal with a whole bunch of angles. We can deal with angles at 3,000 degrees. We can deal with angles at 50 degrees, negative 40, whatever. So we're going to get away from the basic concept of just 0 and 90. We're going to move away from that. So And I talk about radian. This is probably one of the things you want to know, or a couple of things you want to know. First of all, you want to know how to change the calculator into radians. I hope you know that. Because most of the stuff we're going to be doing in math is going to deal in radians. Central angle is an angle in the middle of the circle and goes through the center of the circle. It's an angle. Radian measure. Now, how many have a definition of radian? Karen, what's the definition?
Any central angles, length of intersected arc divided by your circle's radius.
Okay. What does that mean?
I
Okay.
don't know. That's actually the book.
That's in the book, yeah. What does that mean? What's a radian? Is a radian, here's a question for you, true or false? A radian is larger than a degree. False.
Oh,
Shannon says true, you say false, I don't like false.
I really don't
A
know.
radian is approximately
The same.
60-some degrees. So a radian is much larger than a degree. How many radians are in a circle? 5, 6, 14,
12.
2
Oh, right.
2 pi radians. 360 degrees is a circle, 2 pi is a circle. Radians. 360 degrees and 2 pi are exactly the same. 360 and 2 pi are the same. One is degrees, one is radians. What a radian is, in terms of this definition, is this. A radian is the measure of this angle. What her definition means is this. It's the measure of this central angle when the radius and the arc length are the same. That's what a radian is. It's when the radius and the arc length are the same measure, that's 1 radian. Okay? 1 radian. How do I know a circle has 2 pi radians? Well, you should have converted the relationship between radians to go from degrees to radians. We multiply by pi over 180, correct? To go from radians to degrees, we multiply by 180 over pi, correct? Remember that?
Yep.
If there is no symbol after your angle measure, what is it? Okay, if I wrote this down and I said I have 23, is that 23 degrees or is that 23 radians? Radians. Radians does not have a symbol. So if there's no symbol there, you have to assume it's radians. So if I told somebody came in the calculator and typed in, if you type in 20 cosine of 23, and you're in radians, and if this is supposed to be in radians, it's going to give you a totally different answer than cosine 23 degrees. 23 radians is a big angle. That's like 3 times around a circle. That's like 363 times. So I mean, that's the huge angle. So that's a couple of things to think about. So to convert from radians to degrees. Now if I took 360 degrees, here's 360 degrees, and I'm going to convert it to radians. I'm going to multiply by pi over 180. 180 goes into 360 how many times? 2, and I multiply across, I get 2 pi. So I got 2 pi radians. Okay? You will get to know that. You will know that very well. Radian measure. Radian measure is an angle formed when the radius and the interceptive arc are the same length. Another way you can think about it, how many know this one? Circumference of the circle. 2 pi r. And now think about this. Circumference of the circle, how long is that? All the way to the long down. Outside the circle. Yeah. The number of times the radius goes into that tells me how many radians the circle has, correct? Divide by r. What's left? 2 pi. That's why I substituted this 2 pi. Your circle formula is based on radians. Circle has 2 pi radians. All these formulas that you've ever been taught will be blown away. Everything says something else. So 2 pi radians as you go through. Very quickly, the radians. Any questions on that so far? First section should have been a lot of terms. Not hard math. Should not have been too hard of math. Should have been a lot of terms that you have to know. What I thought about doing with math term side is going like this. We have a test coming up for a little while, probably next week sometime. You know? And I thought of different ways of getting terms. You putting down what a definition is. Not the book definition. You write your own definition. Like if I post a word on Edmodal or something like that and say, post your definition to this. And that would tell you if you're right or wrong. You used to write the definitions. I don't like book definitions. What's that? They get very confusing.
So you didn't even like it once you just put book definition.
No, you have to put your own definition, but it's not going to be point, but it's going to be getting you used to writing the definition when you get to this test where you have to write definitions. And it's not just me correcting it, it could be anybody in the class. That's where you would get points if you go back and say, this is a counter example to your definition. Now, if I wrote this, check out, what is an angle? An angle is 2 rays put together. That make sense? Okay, 2 rays put together. Is that a definition? Is that an angle? Okay. 2 rays at the same vertex.
2 rays combined at the opposite ends of the arrows.
Now, if I go by the book, how about this? I don't know. A ray, actually, an angle is not 2 rays. An angle is this. An angle definition of an angle is this. And an angle is 1 ray rotated around a vertex, starting with the initial side, ending with the terminal side. That's a definition of an angle. It's 1 ray rotated around the vertex from its initial side to the terminal side.
Almost being said like on the Emoto, it's one ray rotated around until it stops, and that's your measure.
Rotated around to, what's the measure? Okay, if I said this, you said 1 ray rotated around until it stops, okay? Where does it start? Alright, so what I did, from the initial side to the terminal side. Because it could be, if I said this, my angle could be here, or it could be, you know, so that's what I say, I want you to get used to thinking differently. This is the hardest part of this one, is to try to think a little different. What could the definition be? Well, I always say, when I look at a definition, I want you to think in it and say, can I think of a counterexample? I mean, it doesn't take you long, like that first one up there. 2 rays is a form of angle. Can you think of a counterexample really easily? Some of them, you know, some definitions will be very vague, you know, acute angle.
Less than 90, greater than
Greater than 0, less than 90, right? Okay, that's an easy definition. No, okay, wait a minute, actually, if you wrote that, acute angle, greater than 0, less than 90. Good definition.
Yes.
Everybody's worried.
Yes, yes.
Yeah, what are you talking about? What's greater than 0, less than 90?
Anterior angle.
Anterior angle is greater than 0 and less than 90. If you just put down greater than 0 and less than 90, does that tell me what you're talking about? If it's not going your way, you make it subway, who knows? I had no clue, you know, you have to have down, what you're talking about when you've got the definition. Okay? So that's kind of where I want you to get to, you know, I want you to get to thinking in these definitions as you go through. There's a lot of terms in this first section. I knew when I was gone the last 3 days, I knew the first section would not be hard in the fact of doing the math. It would be hard in during the terms. Radian measurement. Okay, what else we have here? How many know the radian measurement off the top of your head? If I asked you pi over 4, what degrees is that?
120.
180.
120.
Negative 180 pi over.
What's one?
What?
I have no idea.
25. Oh, close. 5 over 4 is 25. Well, we had a lot of those.
It was 185.
5 over 4. How about 5 over 3 pi over 4?
120.
270.
360.
Did we just say 45?
80.
3 pi over 4.
It's 360 plus 180.
What'd you say? 135.
Look at you, cheater.
You fucking eater.
Don't look at your book.
That's
3
just.
pi over 4 is
135 degrees.
You do like 180 times.
How do you get the angles? How do you get the degrees measured?
180 times 3.
3/4 of 180. Okay, 3/4 of 180. I always just take 180 divided by the denominator and then times by top.
So 180 divided by
I knew
4.
180
I thought it was
divided by
180 divided by 4.
We do 180 divided by the denominator.
And then times it by the top number. So
Yeah,
180
what
divided by
about
4 is 45 times 3 is 135.
What about pi? So then try to times by
Pi cancels off when you change degrees. Pi is 180 over pi.
I just plug in 185.
So, but couple of things to think about. How do you graph? Now, when you get through this, you're gonna have a big chart. One of the easiest quizzes you're gonna have this whole semester is one. I just give you a whole unit circle. You're gonna fill out all the values.
like the degree measurement.
This is degrees, measurements, and radians, and sine, cosine, everything like that. You're gonna fill in all that. I give you a hint. I made you memorize it.
A lot.
Okay? And I'm gonna show you tricks to memorize it. Now, I'll give you a hint. If you do memorize them, it'll make your life a whole lot easier for trigonometry. Right, Jordan?
You need to know these.
You do need to know, because you're gonna be using these left and right. When I took trigonometry calculus in college, I never did memorize them. I memorized them for the test, and that's it. That made life miserable, trying to memorize that whole chart, they did for the test.
This one?
So,
This one that has like the radiant, this one right here?
no, I'm not the whole circle,
The circle?
but more. But more. So,
Oh, see, that's
it's
one.
not hard to memorize. What is trigonometry based on? Two triangles. A 30-60-90 triangle and a 45-45 triangle.
Oh.
You did those before, right?
Yeah.
Geometry. That's what this is all based on. to start with. We're gonna base it on two triangles. So, when we get into this, knowing what these measures are, I'm not gonna I guess you can do it by hand every time and say back 13 pi over 4, okay, 13 pi over 4, what is that per degree measure?
Well, 180 divided by 4 is 45. 45 times 13.
One.
I'm gonna guess and say
585.
Okay, 585. Real long process. 585. Okay, now that's a tough question. 585, where is that on the unit? Where is that?
That's what we'll circle
Let's go
around,
around,
360, and then
around.
585 minus 360 down in
225.
Remember us doing this.
What'd you say?
225.
225. Where's 225?
225, well, 180 is down in the third
right here.
quadrant.
It's right there.
Quad. Down this way.
Down this way? Like down here?
Yeah.
So to label this angle, I would label it like this.
Yeah, sure.
Oh, there's so
Like
much
that.
fun.
No,
Yeah.
no.
Yeah, because it's all the way
Looks
around
good.
and south.
All the ways around one time and then always back around again, right?
Yeah.
585 degrees. So we're gonna have this value in here, right?
So we can just plug 180 in for pi.
It could, but I mean, it's not all the time. If I asked you what the sign of 13 pi over 4 is,
The sign? Wait, it's opposite over.
This
Oh, I
sign.
know hard.
so, the 13 pi over 4, where is this at?
Hi, Brianna.
That's
We will get to it, I'm not there yet.
You mean
Sign of 13 pi over 4 is something we're gonna get to in a little bit.
It's opposite over.
What?
That's what's going on, guys.
Okay, guys.
Oh, what?
In my book it says 0, 0, not 1.
Your book is there.
Our book doesn't have the.
My book is
Yeah.
Zero degrees. Okay, shh. This is a unit circle. And I want you to know this unit circle.
Are we gonna get one that looks like that?
I'll put one off of it.
Because this is kind of.
You can go online, but this is kind of a messy one here, but notice the unit circle. Notice on here you got 0, 30, 45, 60, 90, 120, 135, 150, 180 so far, right? 210, 225, 40, 270, 300, 315, 330, 360. Those are the angles you're gonna have to know. Now, the reason I know those is this. 30 back to the beginning is a 30-degree angle, right? This one back to the axis is a 45, right? This one back to the axis is a 60, and then we got a 90, right? If I take this angle, which is 120, but I go back to this axis, what's there? 60. If I take this one back to the x-axis is 45. 30. Now if I take this one back up to this axis, 30.
45, 60, 60, 30, 45.
What two triangles did I tell you you have to know?
30, 60,
30,
90,
45.
That's a lot more. Just do 0, 90, 180, 270, 360.
Okay, points on the axis now. Okay, I'm gonna kind of give you some pointers. Look at the top here. Okay, if I'm looking at my x-coordinate,
Hey, look at 3, 2, 1, 2, 3.
okay, 3, 2, 1,
1, 2, 3.
3, 2, 1, 1, 2, 3.
Oh my God.
This is kind of easy.
If you go on the other one, 1, 2,
3,
3, 2, 1.
Where are you getting?
Look at the x-coordinate. Don't worry about the denominator.
Okay.
On this side, 3, 2, 1, 1, 2, 3.
Oh.
And the bottom is always true.
Same, but you have to remember that this 3 has a square root, the 2 has a square root, and the
They
1
all
has
square
a.
root except for one.
What's that?
One is square root.
I will talk about that in a moment. Okay, knowing those values, right? The other thing you have to know is which ones are positive and which ones are
Negative.
negative. First quadrant, all of them are positive. Second quadrant,
Negative.
your x-coordinate better be negative because in the second quadrant, x is
Negative.
negative. In the third quadrant,
Negative.
both x and
Y.
are negative, so both are negative.
Oh.
Fourth quadrant, x is positive, y is
Negative.
negative.
What are the other, the pi over 6, pi over 4?
That's your radian measure. If it's 30 degrees, how many radians?
Oh,
Where
right,
is it?
so it'll be 6.
Pi over 4. Pi over 2 radians, right? This is a unit circle. Okay? A unit circle is a radius of 1. If I pick any of these points, I don't care where, I'm going to pick this point right here. Draw a line. My radius is 1, right? If I took my x point and my y point and squared them and added them together, took the square root, what am I going to get? 1, because this circle is radius of 1. Always going to equal 1 no matter where I pick from. If I pick this point right here, I took my x coordinate squared and my y coordinate squared, add them together and take the square root, I'm going to get 1 every time. That's how a unit circle works. Now, how do I get these values? No, it's not that yet. How do I get those values? Let's think about this. What is that? Okay. Carter, you told me, what would you say? 45, 45, 90 triangle right there, correct? What would this side represent? This side would represent my x value. This side would represent my y value. Everybody agree with that?
Yeah.
What do we know about hypotenuse? What's that? Oh, what is the max? What is my hypotenuse? Oh, it's 1. Hypotenuse is 1. Everybody agree with that? Okay, now let's go back to geometry days. Oops. Here's my triangle, right? Back in geometry, or last year we did some of it too, we had a 45, 45, 90 degree triangle, formula triangle, correct? Do you remember what the formula was? X square root of 2?
Yeah. 2 square root of x, x square root of 2.
Okay? So two sides are the same. Okay, if I look at this triangle I just drew a second ago, my hypotenuse is 1, would represent x square root of 2. So really x square root of 2 is equal to, if I solve this down, I'm going to divide by the square root of 2. What can I have in the denominator? How do I get rid of a square root? Times top and bottom by the square root of 2, and I'm going to get the square root of 2 over 2. That's going to give me my x, which would represent this side here, right? And it would represent this side there, correct? Since both sides are the same, right? So my x is x square root of 2 over 2, and my y is square root of 2 over 2. What was my x, y? Point? Everything comes from a 30, 60, 90, and a 45, 45, 95 on this triangle. Everything comes from- If I look at 210 degrees, let's do another one. Let's do 210. Let's look at 210 degrees. 210, but we always draw it back to the x-axis. Okay? If I drew that triangle out, I'm going to draw it right here. I have a little upside down here. This side over here is going to be x, this side over here is going to be y, correct? What is my hypotenuse length? 1. That does not change. On 210 degrees, this angle right there is what? 30 degrees. This has to be 60. Another one has to be 90, correct? Okay, now let's move down for a second. Now let's see who remembers geometry. Back in geometry days, we had a 30, 60, 90 degree triangle, correct? The formula triangle went like what?
X, 2x, and
X
x.
Okay, so let's start with Cameron first. X, where's x at?
Longer leg.
Nope.
No.
Shortest leg.
Shortest leg is x.
2x.
2x and x squared root of 3. The hypotenuse is always 2x, and the longer leg is x squared root of 3. You might want to write that down because you will use that a lot. So the hypotenuse, always opposite my 30-degree angle is x. Always opposite my 30-degree angle is x. X squared root of 3 is my longer leg, and 2x is my hypotenuse. Okay? So now on this one, what do we know my hypotenuse is? What's my hypotenuse in this triangle? 1. So 2x equals? 2x is equal to 1. So x is? So if this side's 1/2, what's this side? What's 1/2 times square root of 3? Square root of 3 times 1/2 would be 1 square root of 3 over 2, correct? Agree with me? Now if I look at my figure going across my point here, what was this coordinate? X. So my x coordinate was square root of 3 over 2, and my y coordinate going up and down was 1/2. Now in the third quadrant, down here, what's my x, positive or negative? What's my y? What's my point? negative square root of 3 over 2, and 1/2. Everything's based on those two triangles. When I did this in college, I had to draw a triangle every single time, so I didn't memorize it. It took me a while, but if you can get them memorized, it'll save you a lot of time. You will be using these quite a bit. You got two triangles, you should memorize. Questions on that so far? So I come tomorrow and give you a blank one of these, you ready?
No.
Maybe,
So, coterminal angles. Let me get to this definition. You go for a second.
yeah,
Coterminals.
find it. Has to be,
What do you think a coterminal angle is?
And
Terminal
wait,
angle.
and
Both.
equal.
Lie top. What is that? And more than one. Whoa, an angle, look at an angle. An angle with a different measure, but the same position on the terminal side. An angle with a different measure, but the same position on the terminal side. Think of that. That's theory definition. An angle with the same measure, but different position of the terminal side. The terminal side is where the angle ends, right? So if it ends here, it has a different measure, that means it has to go all the way back around, right? How do we find coterminal angles? Yeah, you said add or subtract 360 or 2 pi. How do you determine which one you add or subtract?
negative.
If it's in radians, you use 2 pi. If it's in degrees, you use 360.
Okay, if it's in radians, you use 2 pi, and if it's in degrees, you use 360, right? So to find coterminal, so if I add down here, I said a 400-degree angle here, and said find me a coterminal, find me a positive angle less than 360 that is coterminal to each of the following. So if I had 400-degree angle and I want to find coterminal angle, I'm going to subtract 360 and I'm going to get 40. 40 degrees is the same as a 400-degree angle. Correct? Same position. Same position. How about the next one, a negative 135-degree angle? If I add 360, what am I going to get?
125.
145. We have to practice adding. It's 200 and some, or 225.
225.
245, I heard 125, I heard a lot of different.
Oh, 360, I'm thinking 300 now.
You're wrong.
How about B down here? Find me the coterminal angle to 22 pi over 3. That is less than 360.
Um, 180 divided by 3. 4 pi.
Wait, did we do it?
60.
Okay, with a subtract 2 pi, right? So this angle is too big. If I'm subtracting 2 pi is the same thing as 6 pi over 3, correct? 6 pi over 3, if I divide that out, 3 goes into 6 how many times? 2, so I got 2 pi, correct? If I subtract that out, what do I get?
16 pi over.
Over 3, 16 pi over 3, am I good? Why?
It's more than double.
It's more than double, it's more than 360, so I have to subtract 6 pi over 3 again. If I do that, I get 10 pi over 3, am I done? No, I'm still above 360. Minus 6 pi over 3 again. If I do that, I'm going to get 4 pi over 3. Am I bigger than 2 pi now? No, so my coterminal angle that is less than 360 is gonna be 4 pi over 3.
Where'd you get the 6 pi over 3?
6 pi over 3, I wanted to get the common denominator. I started off with 2 pi, I knew I had to subtract or add 2 pi, correct? So I split 2 pi over 1, and common denominator would be 3. So I multiply top and bottom by 3, so I get 6 pi over 3. Oh, okay. That's where I get that from.
Can you just start with 6 pi and then multiply it by 3 when you move your denominator? 'Cause can you just start with 6 pi over 1?
Could you
And
probably
then go get your denominator of 3 and get 18 pi over 3?
You could. You know, it just depends on how many times you're gonna go. You know, I might ask you for 4 coterminal angles. The reason we would do this is because we don't like working with large angles. 22 pi over 3 is a huge angle, okay? But if I took the sine of 22 pi over 3, and I took the sine of 16 pi over 3, and I took the sine of 10 pi over 3, and I took the sine of 4 pi over 3, they're all going to give me the same value. Because they're all the same position. That's kind of why we break it down to always between 0 and 360, because we know those angles in that chart. And so we work with that chart. If we can break it down to those measures, it makes math a lot easier. I don't know where 451 ends up here. Length of an arc, I think you did. Did you get into linear speed and velocity?
Oh god,
Um,
we didn't know
I got to the problems, but I didn't know how to do them, so I just stopped.
So we'll deal with linear speed and angular speed tomorrow, I guess.
We got too far on it.
We should be finishing up to that for the day, and then I'll get other things, and then tomorrow.
Today and yesterday, we did not have that.
What's the watch video?
Oh, it's a big
Yeah, well, we count a different way on like the graphing part, we still get the right like angles, we were counting it right. We were teaching ourselves, how to do the average section on that part, we went out of the book of the next section, to figure out how to do it. And when I saw the part where it was 30, 45, 60, 90, and we were counting it differently. And but we were still getting the same like right answers.
So we're gonna get all those. Next section, we'll go through to the next section.
Yeah.
Why water?
a lot of memorization.
You want some skin?
Maybe we don't have that number.
On your own.
Did you tell us they were due?
I need some donations.
On your own, straightening itself out.
Well, if you finish on your own too, so it's on November 1st.
Well,
Yeah.
that's.